Oh, so much going on in the world, Steve.
Yeah, I know. I got all these people trying to tell me that COBOL does pay very well on Twitter right now.
I, I,
It's not,
what was the context of that? Did
no
you,
more
are you,
nuance than that. Earlier today, a discussion with some people over chat, COBOL being like the meme of like COBOL being a good job you can get paid for heavily came up, and one of my like more harmless conspiracy theories that I believe in, not that I believe in harmful ones, but like a conspiracy theory that happens to be harmless and not something terrible is that COBOL is not actually a well-paid profession. It's just a thing people say. Because like if you try to go look for a high-paying COBOL job, they're like, oh yeah, it pays extremely well. Like we pay $50,000 a year, which outside
right,
of the context of software is a great
right,
job, of
right.
course. But
Also,
this isn't the
50,
like don't learn Rails because the banks pay for COBOL programmers extremely well because there aren't any of them anymore. Like I can't actually find evidence that that kind of job exists other than a couple unconnected like anecdotes, but like if you like okay, the mean salary for a COBOL programmer in Austin is like $70,000 a year or whatever, for example, which
and are
like
you
great.
certain that this is not denominated in 1963 dollars, which would actually be real? I
Yeah,
mean,
yeah.
it's possible. There's a local hot dog joint here in the Bay Area. Did you ever go to Top Dog? Steve, you've been out here to go to
I
Top
have
Dog.
not been to Top Dog, but maybe in a couple weeks whenever I'm out there,
I don't
we'll go.
know. I don't know that it's worth it. Top Dog is kind of an experience. So it is run by ardent libertarian, an ardent libertarian of admirable purity that I feel like we were all once. It's like, wow, this is like
Sure.
me when I was 13, just like straight up. And then there's kind of like this libertarian propaganda around the hot dog joint. And if you wish to pay for your hot dog in the currency from the last year in which silver was actual proper silver was used in the coinage, which I believe is 1969, then you can pay 1969 prices. So if you wish to pay for a hot dog with a dime, you can do so. It just has to be a 1969 dime that has silver in it. And so I'm wondering if the COBOL programmers, it's like, no, you get $30,000 a year in silver. It's actually, no, it is. It's a great gig.
I
But
feel
not
like
that
it's a
bad.
good sign for this podcast that both of us had to immediately take a step back and qualify a statement halfway through like the first sentences that we both said.
Is that, wait a minute, is that foreboding? I feel like I'm
I
being.
said I think it's good for boating.
Oh,
This is
yeah,
gonna be a
good
good
for voting.
episode.
It
Yeah,
is
yeah.
good. It's good for voting. Okay, so Adam is attending to sick children. Adam very much wants to join us, but is his household duties have called, his nurse duties have called, and Adam is of course doing terrific work as a parent. They're attending to the ill children in his household. So Adam, to a speedy recovery for all in your house. Okay, so we got here. So the tweet here is apropos of absolutely nothing that we're talking about Fred Brooks's classic, but of course it isn't actually apropos of absolutely nothing. In fact, it's the opposite of that. What is a podcast episode that is a subtweet, Steve? Is that a sub episode? What do you call that when you have an
Yeah,
entire podcast episode that is a subtweet?
I mean, aren't most podcasts kind of sort of subtweets when you really think
Oh,
about it?
yeah, that's true. Okay, so and I think definitely some people were hitting me up about like, what have you been like subtweeting so much about? And so just kind of have it out there, so we're all kind of so it's actually not what we're going to talk about, but this is actually important context. So a company, Red Planet Labs, is going to announce tomorrow at 10:59 a.m., a time that comes up quite a bit, that they will be releasing a programming platform that promises 100x programmer productivity. And I think it's fair to say that I personally am skeptical, but that's not important right now, as Airplane might say. I am skeptical. I also am, by the way, I think there is absolutely going to be real technical depth to whatever they announce. There will be technical depth for certain. And the question is it 100x programmer productivity? And also, and I'm sorry, Steve, I can't, I know I would like to think that I'm above this kind of a pot shot, but apparently I'm just not. in the email that they sent out to folks on their email list, they believe it is the biggest paradigm shift in software engineering in at least 30 years. As if the internal debate was, is this the biggest paradigm shift in 30 years or 60 years? And they kind of split the baby with at least 30 years. So, you know what? Who knows? It's possible. But maybe it's
but the part to like bring this up is basically like, this is not what we're going to talk about for the episode, but this is what got us starting to talk about, like, what does 100x platform, like, how would you evaluate if this claim is true or false?
How would you evaluate this claim is true or false?
Yeah, and that means you have to get into like, what does it mean to try to like enhance someone's productivity 100x?
What does it mean for 100x? I also would like to say that 100x is the new 10x. I swear when I was coming up, this was 10x. And this paper only Brooks's classic does talk about factors of 10, not factors of 100. We actually did a 10x on our 10x, literally, to get
10 years. They did one 10x a year, and so it's going to be 100x total.
That's right. Which is, I mean, I think it's fair to say, like, step function in the software engineering paradigm. And as someone had kind of mentioned this, that like, hey, this is you should go back and reread No Silver Bullet. And Steve, had you read No Silver Bullet back in the day?
So I was required to read it as part of one of my earliest college classes, and like I hadn't seriously revisited it since then. I mean, obviously, there's sort of like the memified way that we take a lot of these texts and then kind of like, talk about their conclusions without going back and reading it again. But like I hadn't until this morning when we were talking about this, I hadn't like revisited it at all.
I was in the exact same boat. I had not revisited it. One thing we do need to revisit just quickly, because Ashley's asking in the chat about split the baby. And now I'm very concerned that split the baby is not enough of a popular idiom for me to be using it as casually as I'm using it.
I thought you were mixing metaphors between splitting the difference and like the parable of the judgment of Solomon or whatever.
I think that's right. And Steve, thank you. And thank you for being willing to chalk up to basically just linguistic incompetence. Get the baby in the bathwater, splitting the baby in the bathwater. Yeah, I kind of had split the difference. But I feel like but splitting the baby is like the compromise. That's not a compromise. I don't know. All right. I think I need to stop dissecting this. Let's just say it was not the bone.
The best way to explain a mixed metaphor is to mix even more metaphors in there. You start, making a good metaphor stew, and then everything is very comprehensible.
A little metaphor bouillabaisse, a jambalaya, as Adam would say. We got a proxy Adam in absentia. I believe that Adam would say that it is a metaphor jambalaya. So Adam, hope we've done right by you by representing the jambalaya. So yeah, Steve, I was in the exact same boat. I think I'd read this, like, I guess as an undergrad. I know I read the Mythical Man Month like some number of years into practicing as a software engineer, but I basically had not gone back and read it since. And just read it effectively recently with all this coming up. What did you think on the reread? What was your take?
So I think that this is classic Fred Brooks in the sense that when I read his stuff again now, it is like so on the money for so much of it. It feels like contemporary, but then there's just suddenly an example or a detail that's like clearly it's very old, and it sticks out like even more than it would otherwise. And so it kind of like it's a very like emotionally jarring like thing to read, because like so much of it seems like it could have been talked about last week. And then he's like, well, of course, there's not enough screen room to see more than one document on a screen, so like nobody's really going to be able to do that. And you're like, wait, hold on a second, like I thought we were talking about how AI is not going to like make programming better at the time or whatever. So he
is like a time traveler that actually doesn't want to get caught, but a payer like trips up every once in a while and says something that reveals his true origin. Like, wait a minute, are you from and Mythical Man Month is this way too. So that's asking in the chat, is it worth a read? I do think it's worth a read, but you definitely have to factor out the bit on secretaries. Do you remember this, Steve? Where there's there's a whole chapter on like what the secretary should do, and I'm like, yeah, we don't. Okay, no, we do. No, that's not traveling as well.
Yeah. I mean, I think part of also like in terms of is something worth it to read, like it's like 15 and a half pages. You can read it relatively quickly. So I think it's worth reading just because it's not like you're like, is it worth watching all the extended Lord of the Rings movies, right? Like you're not putting in a lot of effort for what you're getting out here. So I think that the worth it is very clearly on the side of yes, you should read this.
Yeah, I think it's worth being aware of. I think that this essay is actually, it didn't like, I just don't remember it really sticking with me. But the essay, I think the essay is arguably like the best part of Mythical. I mean, if you're really going to read one part of Mythical Man Month, like this essay is not bad. It travels pretty well, and there are some things you just like get like, wait a minute, okay, did you just refer to Constantinople? We don't actually call it that anymore. But it's I think it broadly travels pretty well. You know, I was looking for other kind of discussions online, and actually, it's funny. I found a podcast called "The Future of Coding," which I had in my queue before, but not listened to. And they did a really in depth discussion of it that I enjoyed. It was super long, like 4 hours long. And I gotta say, like I was starting to listen to it as I'm in like Costco buying a bunch of stuff for a Scout barbecue yesterday. And they talk about like, you know, well, it's the first podcast of the year, we should make predictions. I'm thinking to myself, hey, we make predictions. That's cool. Another podcast makes predictions. And then they're like, yeah, you know, I was listening to the Oxide and Friends, and they make predictions. I'm like, hey, wait a minute, that's just they're talking about. I thought that's really neat. So, Future of Coding, folks, thanks for the shout out, and really enjoyed listening to your podcast as well and the discussion there. It got very philosophical. So, Steve, I don't want you. I think of you as more than just my go-to for philosophy. I want you to know that. I don't want you to feel insulted that exactly that you're not just the philosophy role player around here. But
it's not just when your co-host is sick and you need a philosophy person. It's more than that specific circumstance.
You know, I knew that was going to come up. Look. Okay, okay, it's true. But here we are. Look, here we are. Let's just make the best of it. You know, they were really into kind of the Aristotelian dichotomy between the accidental and the essential, and as a kind of the thrust of the paper. And I didn't quite infer that as the thrust of the paper, but I don't know. But then it did cause me to kind of go back and reread it more closely. Can you give us some? Can you philosophize? Do you do that on demand?
So this is not exactly what they said, but it's close enough, and I think it's a good way to ease into it. So I'm going to start slightly somewhere else. Larry Wall has this idea called the waterbed theory of complexity. Now, I don't know if you've ever been around a real waterbed, but if you push onto one side of a waterbed, it makes the other part rise up, right? You have a bunch of water inside of basically a giant balloon, and so the like amount of cushion doesn't disappear; it just gets displaced into a different area. And so Larry like really strongly believed that with complexity, there's like essential complexity and accidental complexity, which this also makes reference to. I'm not sure if he got it from here or if it's just a similar thing or whatever. But the idea is kind of like there's some parts of problems that are just are complex, and it's not actually possible to simplify them. It turns out that the real world is a messy place, and complexity exists, and therefore you can't really get rid of that complexity. You can only move it around into different places. And so I see this come up a lot when discussing, for example, like why some people talk about why they don't like the Go programming language is because Go kind of says, like we can introduce this simplicity. And a lot of people will say, well, no, I don't actually believe that it's reducing the complexity anywhere. It's just moving it to other places. And so, you get endless on arguments. And so I thought this section of No Silver Bullet was really interesting because, they also talk about this general idea of like there's parts of a problem that are irreducibly complex. And I liked specifically, not just because I went and saw Oppenheimer 3 freaking times and Einstein was part of that, but like they make reference to this Einstein quote. Let me grep for this real quick, because should I say that before? Yeah, so like Einstein repeatedly argued that there must be simplified explanations of nature because God is not capricious or arbitrary. But no such faith comforts the software engineer, which I thought was, pretty solid. Like, and so they get into this kind of like, where can we, if we're trying to simplify things, like, can we even simplify stuff and all that? And I thought that was pretty good.
Yeah, I thought that was great. And it kind of gets to I think Brooks's fundamental thrust is against those that kind of offer these single solutions, because his kind of point is, if you don't attack the essential complexity and you only attack the accidental complexity, the upper bound on what you can do from a productivity perspective is the elimination of all accidental complexity, which is not enough to give you a factor of 10 increase unless you're spending 90% of effort on accidental complexity, which I thought was like, I mean, that's a good point.
Kind of like an Amdahl's law style argument, which I continually cite as like the most important and useful thing I ever learned in my computer science degree is Amdahl's law, which is
yes, getting Amdahl. Yes, absolutely. And I actually, it caused me to reflect. I'm sure you as well, Steve, in terms of like, all right, so take something like Rust. Rust really eliminates a lot of the accidental complexity, and you are left with the essential complexity. In fact, you're like staring the essential complexity like dead in the eyes. I felt.
I think on Rust's best days that is true, and it's not always. That's the aspiration, right? Like I don't think it always lives up to that, but that is where a lot of the complexity does come from. Is like, well, just turns out this domain has some irreducible complexity into it.
Yeah, and I think, even when you think about like something super basic, like how does this function return an error? And Rust really forces you to confront that accidental complexity, and kind of you got to boil it down to the essential complexity. Like you're not allowed to actually no, we're not going to use sentinel values. We're going to actually have some types, and you're actually going to do this in a way that you actually have to go deal with it. Actually says strings, totally. Oh my God. And there's so many times when especially when learning Rust, when Rust felt really, really pedantic, you're like, oh, Jesus Christ, Rust. It's like, come on. I mean, it's like, you're technically right, but geez, can't we let this one slide? And then you realize like, no, this is actually forcing me to deal with what I'm actually doing and the consequences of my actions and what is the essential complexity here. So I don't know. It did cause me to kind of rethink it.
I think it also feeds into a lot of the beginner anxiety when learning Rust, because when virtually every function that you call returns a result, and you feel like, oh God, do I got to figure out how to handle all these things? There's sort of like a kind of almost want to make those like bell curve memes where where you start off, you're just calling unwrap on everything, because that is like, I am overwhelmed by this complexity. I don't need to think about it. I'm just going to blow up on any error whatsoever. And then kind of when you get to be an expert, you're like, yeah, just toss a question mark on it because I don't need to handle the actual error here, and I don't care what kinds of errors they are, just like pass it up the stack. And then there's kind of the middle area where you're learning and you're like, I didn't realize that changing the current directory of a process could fail. Like I didn't know that was like a thing that could happen, and now I do. And like, oh God, there's like 15 different ways that this function can fail, and figuring all that stuff out. So so I think that like that's where a lot of the folks that are trying to either improve Rust directly or come up with successor languages to manage this complexity, because there are some folks who do believe that Rust's complexity here is not actually accidental or is not actually essential, and have several strategies for trying to reduce it. And I'm excited to see how those like develop further on in the future. So we'll see. But yeah, totally.
Yeah, that's interesting. And I think you can get like a kind of that interface between the accidental and the essential. There's definitely debate to be had, which is which. But I also feel that like at the extremes, it's very clear that like, no, this is accidental or this is essential. And I feel that what Brooks is addressing is like the things that are going to really take a big swing at that accidental complexity are the things that are going to kind of hit this stuff that is indisputably accidental. And definitely. I mean, and there are
to make the argument Brooks kind of makes in some parts here. If you made the borrow checkers trivial for every programmer, Rust would still have things you would need to learn about it. It's not like it would be 100 times easier to learn Rust if the borrow checker was just trivial. Like there would still be a bunch of different things that, depending on what your background is from, you may not have dealt with before, or like all sorts of other things. So like even that would not necessarily achieve, the goal of an order of magnitude improvement in ability to learn Rust.
Totally. And I think that, and actually the thing that impeded my own ability to learn Rust is I was trying to port something from C to Rust, something I wasn't porting it per se. I had implemented it in C and I wanted to re-implement it in Rust. And I was truly latching on to my accidental complexity and trying to implement it the same way I had done it in C, namely with a doubly linked list. And Rust does not want you to do that. Rust is like, you need to leave that accidental. That is accidental complexity, my friend, and you must leave it in the past now. That is, we need to get to the essential complexity of your problem, and we need to get. You almost want to compile a message that tries to coax someone out of their accidental complexity. But I was really latched on to this implementation detail that, in hindsight, was accidental complexity, even though I don't think I would have thought it at the time. And I thought that was like what was so eye-opening about Rust. It's like, oh, wait a minute, that actually is accidental complexity. And what is the essential complexity? What am I trying to do? And what would I do were I not concerned about performance? And I put that in quotes because that Rust program outperformed the C program, which is totally surprising. But I just think it's really interesting to kind of like look back on Rust as taking on, in particular, this accidental complexity. But on the essential complexity, I mean, it's not like you're on your own, but like, kind of hard. It's like I don't know that Rust really aspires even to take on that essential complexity. I think it really aspires to get all of the accidental complexity out of the way. Is that a misread?
I am unsure. I definitely think that some people would think that. I don't know to what degree it's being accomplished if that is an explicit goal, but also I have been sort of out of the loop for long enough that I'm not entirely sure what current leadership's thinking is on this topic exactly. I do think it's really interesting that we sort of, I mean, obviously we latch onto Rust because it's a thing that we both love. And, this is the Oxide podcast after all. But like the number one thing that Fred Brooks is like, so I was gonna ask you what you thought the like most jarring example and the most current day example things would be in this paper. And I think one of them, to like half before you get into your picks, just to transition as we start talking about Rust stuff, like the number one thing under the hopes for silver is Ada and other high level advances. And I think this one kind of walks the line because it's very old, because it's sort of like, we'll see if this Ada thing shakes out or not. Which, we know now the degree to which Ada has shaken out or not. But like you could today write the same section and turn the examples into Rust. And I'm pretty sure I've like read it as a Hacker News comment before. And so it is like very interesting to me that, one of my favorite, maybe not literal silver bullets, but let's just say, 60% silver seriously wounds werewolves instead of, totally getting rid of them, is one of the things that Brooks is like, nah, totally worthless.
In terms of Ada itself, or
well, he says Ada and other high-level languages. Like his argument again is this 80-20 argument, where like he basically said like going from assembly language to structured programming was the 80% increase in like programming languages as a way to tackle these problems. I forget.
But like, he does actually. He ends up being, in terms of talking about object-oriented programming, he thinks that object-oriented programming does do this ultimately, that it's not a silver bullet, but it is a hope for silver in that it actually. So I think he's kind of got both sides here in terms of like, I think the Ada thing. Okay, so hot take. I think he may be taught, even though he says Ada and other high-level languages, I think that may be a reaction to Ada itself. And I think that Ada hurt itself by being too preachy. I think Ada. And I think, I think we all have kind of a natural resistance to the Rust evangelism strike force and people talking about, rewriting everything in Rust and kind of the damage that it can do when something is kind of being sold as a magic bullet. And Ada was sold that way. And definitely object-oriented programming was sold that way. I mean, it was absolutely sold that way in the 90s, especially. And then Java was absolutely sold that way. Java was the magic bullet. And, Java was really important in a lot of ways. I mean, obviously, but I think that it was a mistake to think of it as a magic bullet because it didn't actually, it didn't actually solve all problems. So yeah, so I was wondering to what degree it's Ada itself. He clearly, he did a Papers We Love. I don't know if you caught any of that. So one thing that is funny, did you watch any of that by any chance?
I did not have the chance to watch any of that.
So I'm just going to tell you, so you can make your own informed choice. You will be eating the fruit from the tree of knowledge and good and evil by watching that. Have you ever heard Fred Brooks speak before?
I don't believe so.
I don't. I would say that if you're not sure, you definitely haven't. The guy has got a crazy syrupy Southern accent, like super syrupy, which is like there's a level in which and there's no love lost between him and Ada. That thing is like recorded when he's like 88, and he is like still going back for more with Ada. He's still just like, wow. Yeah. So he definitely is like, Ada definitely rubbed him the wrong way. There's also a really good and interesting point about that. He's like, in the responses to my essay, I noted there were many people that said, I have a silver bullet over here, but nobody said, this is the silver bullet I'm using over there. I know I sound like I'm an antebellum.
That's wonderful. Honestly, that makes the whole podcast already, as far as I'm concerned.
Oh, it is. But I thought it was actually a really interesting point that he was making. That like, hey, that's funny. Nobody is talking about the silver bullet of someone else's that they're using. Oh, it's always your silver bullet. Huh.
It's always the snake oil salesman and never the snake oil affiliate marketing.
Totally. It's never the snake oil testimonial, is it? It's always the it is. It's always the same. Well, and I think that like that is like part of the issue is that like we have so much abstraction that we get mired by it and frustrated by it, that somehow all of it does leave us amenable to oversimplified answers. And sometimes those are oversimplified answers that we think that we have found. Like I have found that this thing that has been important for me is going to be revolutionary for the universe. It's like, well, it's actually important for you on this problem, but maybe it's not as revolutionary. There's something about software that does leave us kind of amenable to this kind of stuff.
You wake up one day and suddenly you've got a FuzzBiz Enterprise Edition. I don't know if you've seen this before or not. I pasted it into the chat, but it's like, how could we write FizzBuzz in the most like enterprise Java way possible? Like there's like 7 config files and like yada yada yada. It's really something.
That is pretty funny. Hold on, I'm trying to get you up here, and so I want to get other people's take on this as well. So Steve, you were asking about kind of like in the specific technologies, because it is amazing that some of the stuff does feel super current. So one thing he talks about as like I think this paper is misperceived to be pessimistic, when he's like, I'm not saying that the improvement's not possible. I'm saying it's not going to be a single thing that yields that improvement. Right. And in particular, because to me, like what this is really before, and the thing what this predates that totally changed software is the combination of open source, the internet, and distributed version control. I argue that those 3 things together did fundamentally deliver a big multiplier. Is it 100x? Is it 1000x? Is it 10x? I don't know, but it's big. It ain't small.
Keep in mind that at the time that he wrote the essay, he also was no longer writing software for IBM. He had already transitioned away from being a professional software engineer to being a professional educator. So
yeah, that's true.
The things that he's talking about is also from some time prior, and he put a decade-long proviso on the prediction. So he was explicitly saying, yeah, within the next 10 years, we're not going to get a 10x improvement. But I would note that I think that the real interesting insight is just the ratio, right? Is what we're doing right now 9/10 accidental? If it's, less than 9/10 accidental complexity, then there is no way that we can get a 10x improvement, because there's not, 90% of work that we can just throw away, which, it's, I think the thing that I was kind of curious about reading it was thinking about it from the lens of a single programmer versus a team of programmers or a company of programmers, and where the complexities lie in the communication between individuals. Because the 9/10 likely bears out over the course of an individual, but over a team, there's some real interesting stuff at play.
Totally. And that's a very good point. And I think things that allow people to collaborate more easily can get to these big multipliers. I mean, that is what like open source internet distributed version control together, they allow for a much better collaboration. And Ian, to your point, we talked about it when we had David Crespo on and Justin about how the open API and using Progenitor allowed them to much more easily, they didn't have to guess about what the actual specification was because the specification is derived from the implementation. So yeah, I think that's a good point in terms of like all the complexities that come from operating on a team. So Ian, do you think that of these kind of purported magic bullets from the past, how many of the ones that have been, how many of them have kind of addressed that element of it, that kind of team complexity element?
I think that there's been a few. Like, I would note, like in the paper, Brooks talks about buy versus build and the fact that over time the best thing to do is likely to buy a module off the shelf and use it rather than write it yourself because of just how expensive it is to produce software. And that, he missed at the time
the open source in 1986, but
yeah, exactly. And he's also still talking about the next decade, so he was pretty on the money there. But like in the years since then, open source has definitely made it significantly easier to buy at zero monetary cost on day one. An open source module off the shelf that can do some of what you want, and the assembly of those modules is kind of a big part of how we write software today, by and large.
So Ian, you kind of got me thinking here about like this essential accidental complexity, if you will, of the team dynamic, which is this really important complexity in the construction of software. And as I'm just like thinking about like what are these big step functions, they are things that either deliberately or either essentially or accidentally do address that complexity. In other words, like the presence of open source internet distributed version control actually allows us to meaningfully collaborate as a species in our fight for the light cone against the AGI. But it allows us to actually meaningfully collaborate. And then I think that obviously distributed version control just allowing for much easier collaboration. And I almost wondered, it's like if you're going to have maybe off my rocker here, but if like you're going to have a big multiple in productivity, it's got to have a kind of a collaborative angle to it. You know what I mean?
Oh yeah, it's got to be a way for multiple engineers to be more productive working together, or be able to elide the challenges in relying on another team to do work on your behalf, and erecting API boundaries between those teams and the efforts of those teams, such that you don't have to know as much about what's going on behind the scenes. And there's things today that are incredibly effective at that. Like S3 is a amazing API for determining for like abstracting over storage. You don't need to know that your files are now stored on 1,000 or 10,000 or 100,000 or 1,000,000 hard drives. That's all kind of hidden behind the API, and all that effort is hidden behind the API. And I feel like that's an extremely effective example of like how this can work, to be able to allow a small group of programmers to deliver software capability to a significantly larger audience. And
that's it.
I suspect that stuff like that is where there's some real interesting gains, particularly in this that's in the large, and I kind of wonder how much of that can be scaled down to like within an individual company when you have teams relying on platform teams to deliver capabilities, and how you can get those delivered more effectively.
Yeah, and that's a really interesting example, because with S3 took a kind of radical approach that anyone versed in storage would have counseled probably against, which is like, yeah, we're not going to actually allow for partial updates. We're not going to allow for partial writes, which would just seem like, what? Like, no, any storage system has to allow for partial updates. And they're like, we don't think so. And that was a big gamble and a big win. And it's interesting to think about S3 as one of those technologies. Steve, one of the ones that I've got to ask you about, because I think like one of the ones that I've seen in my lifetime, I think Rails was a really big deal and was a really big step function. And it
was a big enough step function. I basically quit my job. Like I was currently, that's pretty funny. At the time, I was at an internship writing PHP, and it was fine, but I saw Rails happening. And when I brought that stuff to like work and was like, hey, we should like consider doing these things, and they were like, no. And I was like, okay, I'm going to do something else instead. And I went and I started a startup so I could write Rails.
Yeah,
that was like, and it was extremely fast and like so much easier to get going. I got a lot farther than I would have at the time, especially 2009. So, a lot of the current technologies didn't really even exist at that point. And Rails was super fantastic.
I was going to ask what year it was, because the DHH video is 2005. Is that right? I think it's 2005. Yeah. And I actually wanted to go back. I didn't get a chance to rewatch that video before today, because it
is difficult to find on the internet, but I can.
Which is crazy. That's like that's a part of our
crazy,
history.
But
Oh no, is it not? Is it? Is it a milkshake duck? Is it what's?
It's not a milkshake duck thing. I will just put it this way. I've heard a rumor that it's for personal reasons for David to take it down, and he doesn't really like people watching it these days. I won't get into the details because they were rumors said to me, and I don't want to say anything. But my understanding is it was deliberately made hard to find these days. But it is like basically, the magic of it in the moment. Like you don't even necessarily need it's almost boring to watch because Rails dominated the space so heavily and won so thoroughly. Like conceptually, obviously, I don't really think Rails is still dominant as a technology, but like the stuff that it brags about are things that we take for granted today when building web applications. And so when he shows like how awesome it is that you can do this, it like doesn't have the same emotional resonance just because like, yeah, of course you can do that.
That's interesting, because the thing I was trying to remember, first of all, I remember where I was when I watched that video. Really big deal when that thing came out. It was YouTube was still really young. I mean, it was only like, it may have been the first year of YouTube even. I mean, it was super early YouTube. And it was the first time that I had a demonstration of a technology over YouTube. And it was arresting. I was like, oh my God, it was 14 minutes long or something like that? Yeah, 15 minutes long.
And pasted it into the chat.
Oh, nice. Oh, yeah. Okay, that's good. So it's DHH and his agents are going to have to work a little harder to hide it from Oxide and friends. So yes, it's 15 minutes, and it is the thing that I was trying to remember. And actually, maybe if you've seen this recently, maybe you can recall, but I don't know to what degree the tenor of the video was, I have revolutionized all of programming, versus I have built a blog engine in 15 minutes. I just remember being like here is a very useful approach for this kind of problem that, by the way, happens to be a problem that a lot of people have. But I don't remember being sold to me as this is going to revolutionize everyone's productivity. It was more just like, hey, here's how I did this. And it was really effective.
And an important thing to understand about David is that he does not care if other people use his thing. Like he wants to tell you, I haven't rewatched it recently, but like I would not expect him to be saying like, you should also use this thing, because Rails is first and foremost his project for him to do with as he likes and is written for him and for his taste. Everybody else is incidental. So I would expect it to be like, I have built this thing that makes building websites incredibly fast and I'm going to be using it, but I would not expect it to be as salesman as you would expect from someone making a use my framework please today, because I don't really think he cared then or cares now if people use Rails.
I gotta say, that is pretty common for these things that are these big step functions that is kind of their genesis, right? I mean that's Graydon and Rust. It's not like use Rust. It's kind of like, hey, this is the Graydon's presentation from Mozilla, was it 2000 and when is that, 2012?
Yeah.
That early
10.
2010 is kind of like, here's some interesting ideas I'm experimenting with. I mean, it's just like the way I feel like Unix was designed to test the file system. I mean, I think, not to put myself in this kind of hallowed hall, but I guess that's exactly what I'm about to do. I mean, for dtrace, like we ultimately designed dtrace for us. Like it was ultimately like, this is the thing that we are like, I actually know this is effective because I'm using it to do my job. And if I would love other people to use it, but I also not gonna kind of like, if they don't, that's fine. I mean, I'm happy. And I mean, this has got me as you can imagine, reflecting on dtrace as well in terms of like because I think what dtrace does for debugging, which is a very narrow problem or a narrow subdomain, is dtrace eliminates most of the accidental complexity in debugging and leaves you with pure distilled essential complexity that does not necessarily make the problem easy. And so one of the things we heard early on in dtrace is like, oh, I'll put dtrace, I'll use dtrace on this problem. It's like, well, you can use dtrace to debug the problem, but you are ultimately going to need to have, like, you are going to actually have to understand the problem. Like dtrace can't actually help you understand it. All it can do is make it easy for you to phrase questions of the system. It doesn't actually tell you what questions to ask, which is honestly the much harder bit. And I kind of feel, which is part of the reason like why I would never talk about like a 100x gain, because it's like, it is an elimination of a bunch of tedium for debugging, but your ability to debug the problem is going to boil down to your ability to debug the problem, unfortunately.
What question to ask is actually why Brooks in No Silver Bullet says AI is not going to help programmers.
That section felt chillingly current, didn't it?
Yeah. The hard thing about building software is deciding what to say and not saying it, right?
This was a year before the next AI winter as well. So it was, yes. I think the tide was like turning against the current state of the art of AI at the time.
The first snowflakes were falling from the late 80s AI winter. So we got Tom and Alex here, so I want to get them in. Alex, actually, if you don't mind, we'll start with you, because you had actually, when we were talking about No Silver Bullet in our internal chat last week, you had mentioned that you'd read it, and it sounds like more recently than Steve and me, and it definitely had an impact as the way you were thinking about problems. Could you elaborate a little bit on that? All right, now Steve, now we use you to debug. Do we know that Alex is...
the current state is Alex is not muted, but is not getting audio from their thing into Discord because the little green ring does not appear at all. I mean, now you're muted again, so you wouldn't, but I would be debugging whatever your connection is to Discord itself, Alex.
All right. We'll go to Tom, and then Alex will come back in a second. Yeah, exactly. Tom.
Yeah, I posted in the chat, but when I was first looking for this paper, which I'm ashamed to say I never heard of before, I found this weird version hosted at UCSF with a different productivity equation. And it's about groups, where it goes down as the square of the number of people. But it has all these, I posted this equation. It's got these very weird constants in it with no explanation of where it came from.
And when was strange. Yeah, and Tom, so when was that? And did this kind of resonate with your experience up to that point?
Well, yeah, clearly productivity goes down with large numbers of people. But yeah, I don't know when or where this paper came from. But it's a version of Brooks's paper.
That's interesting.
I also wanted to say I got to meet Fred Brooks back in about 1980.
Oh, wow.
He was a character even then. In his office, he had a big row of timers, mechanical timers, and whenever he switched what he was working on, he'd hit the appropriate timer so he could try to keep track of his own productivity.
Wow, he was like a tailorist for himself.
Yeah, it was pretty strange, but also the incredibly sugary Southern accent. So
Okay, do you feel that I was overplaying that? I mean, do you feel
No. But
It is
I
possible.
I was a young whippersnapper at the time, so I was just in awe that I got to meet the guy at all. So,
It's possible the discrepancy is because the version you found is supposedly a direct reprint of the IEEE Computer Volume 20, Number 4, April 1987, whereas the version that we linked is reproduced from the Mythical Mammoth Anniversary Edition with 4 new chapters, 1995. And so I wonder if this is a modification that Fred made in between versions or something. Or is like, yeah, different versions of a preprint, because it's like it itself is reprinted from some conference in 1986 or whatever. So
the other thing I want to mention, which he dances around some, is this whole specification is the hard part. And I've always maintained that if you could formally specify something, you can just compile the specification. Right?
right.
It seems like people don't say that directly enough, but that's kind of the whole point of software.
Yeah, is to kind of be in that gray area. When he talks about, I do think it's interesting in terms of talking about conformity as a constraint, and how the conformity is a, can't even remember if it refers to it as accidental complexity or essential complexity, but it's complexity at any rate, that a magic bullets, silver bullets, are going to have a hard time addressing the conformity requirement. And I feel like those have only grown over time. Those conformity requirements have gotten a lot more complicated over time.
It's a day-to-day engineering thing. You know, the principle of least surprise is you should conform with what other people are doing, or else it just slows them down.
Yeah, and actually, Tom, as long as you hear, so I would, two other kind of points that I'd like to make about this, to kind of put it in its 1986 context that people may be, I think, confused by. One is he talks about rapid prototyping as if it's a totally new idea, because it is a totally new idea in 1986. Things were very, very waterfally. And the idea that you would, and I think he talks about this in, I think, is it in the update for No Silver Bullet, where he talks about how the big insight that he had is that software is grown, not built. Steve, was that in the original essay or is that in the update? That may be in the, yeah.
Sure.
Yeah, if you didn't read that recently.
Alex mentioned in the chat his audio is not working, but he wanted to say that just so we get it in the actual recording of the podcast, that he thinks the essential thing of Brooks is the quote that I just said. The hard thing about building software is deciding what to say, not saying it. I think that statement generalizes to everything about the construction of software. That's why communication systems, collaboration tools, et cetera, can help so much, because they help people decide what they need to say. So
that's a very good point.
Hopefully Linux Audio will work for you in the future, Alex. But thanks for leaving a comment.
Linux Audio, essential complexity or accidental complexity?
We have like a half an hour social meeting at Oxide, and almost every morning somebody joins and like can't talk for some reason, and then when they finally get to talk, they're like, "Sorry, it was Linux Audio, my bad." So it's a common issue. Says
the Windows user, like, look. I know
I wasn't saying it. I was just acting smug. I wasn't going to go so far as to be like, my audio always works.
I was actually saying it. It was merely dripping from every word.
I will say that once I switched giving presentations, like, oh my God, this projector just works now. It's like I went from like, I literally handed someone who runs a theater in Denver, like, if some weird Linux person comes in, hand them this piece of paper, and I wrote the like command line to set the freaking like X settings to be the same as their weird refresh rate on their projector or whatever. And to go from that to just like I plug the computer in and it projects things has been very nice. So there are obviously lots of other limitations to Windows, but multimedia working by default is not one of the problems.
It may be a 100xer in terms of your projector productivity.
Moving from Pulse Audio to Linux or to Windows is a default sound. Yeah.
Yeah, it's a big bump. So, and Tom, when this came out, so then the other thing I wanted to say, because I think that this came up in the either in the revisiting of it. So Brooks revisited the paper 10 years later. It's really pretty interesting. But and maybe I think it's actually sorry, it is in this paper, because he talks about like kind of the great hopes for the future. And one that I think people have latched onto, and is this idea of great designers, is finding folks who can really develop great software. And I think you've really got to take that one in its 1986 context. And Tom, would love to get your perspective on this, and feel free to disagree. But software really was very subservient to hardware for a very long time, and it was not its own domain. Most universities did not have a computer science program until the very late 70s, 80s, or 90s in some cases. And so it's not thought of as its own domain. And so the idea that you would actually specialize in software it is kind of ridiculous in 1986. And that's part of the reason why he's expressing it like it's a novel idea to actually like focus on this as its own craft.
There was a lot of professional software recognition in the mid 70s. And,
But Tom, what is your degree? Your degree is not in computer science, surely.
It is double E and computer science. They were the same
department.
Computer
science.
So,
all right.
Yeah.
All right. I stand corrected. It's all right.
Which I think they added. I'm trying to figure out when they added computer science to the double E name, but it was early 70s.
Yeah, I mean, total trust but verify.
I graduated in 78 and went to work for Amdahl, and the Mythical Man Month was the first required reading there.
Oh, that's interesting. So you would read it when you arrived at Amdahl?
Yeah, it was the Bible.
Huh. And did Amdahl...
And Brooks cites this incremental programming reference from 1971. So that's kind of how far back some of that goes.
Right, and this is in the paper, incremental development. Grow, not build software, which I think actually is important.
Yeah, that's a really important insight.
Well, and I also love the fact, Steve even talks about demo day when he says the morale effects are startling. Enthusiasm jumps when there's a running system, even a simple one. And I actually think that's what DHH is tacking into too. With
absolutely.
It's like, this is a real running system. And now I can you can make it better now. And you can understand
one of the biggest things Rails did was to like marginalize databases, basically. And part of the reason for that was just that like to get a web app up and running, you had to deal with database crap before you could even get your hello world on the page. And just being able to be like, you don't even need to start a database or write any schemas or do any of that. You just kind of like write a couple commands and now all of a sudden your thing is working. Was like shocking how fast you could get to something useful.
And the morale boost, the concomitant morale boost. All right, so Stephen, what are some of the other things he talks about in terms of specific breakthroughs or putative silver bullets? He talks about AI. He talks about expert systems. How much have you been exposed to expert systems? Is that something you'd...
Not directly, but I'm aware of the term, and I thought it was really interesting that he chose to partition AI into like AI and expert systems, because I found the AI thing to be pretty on point for what we talk about with AI, and then the expert system things to be like, oh yeah, that's right. That's a thing that people thought would be good or something. But like, I haven't had any experience. I don't think I've ever used something that was like sold as an expert system. I heard about it.
Very 80s and 90s, as Matt is saying in the chat. Yeah, and expert system. And I think that actually, I think they're kind of due for a resurgence in terms of like dealing with this kind of AI hallucination problem. You actually are going to need some expert training here, whether it's an expert system or not. I bet there's some interesting lessons to be learned from expert systems. But it was very much the fashion of the day, where was expert systems and distinct from AI for sure. What did you think about you got graphical programming and program verification? I'm eager to get and automatic programming. I'm curious your take on all three of these.
Yeah, I think it's really interesting. I think the last one is probably the one that I thought was very accurate for today. Like I was just thinking Copilot with the automatic shenanigans, and like also the AI stuff. But I don't specifically remember the graphics part that well, to be honest with you. Oh, graphical programming, not graphics.
Graphical programming.
Yes.
Not graphics programming.
It's one of those things. So like the only graphical programming thing I've ever seen succeed is Scratch, and maybe LabVIEW, if you consider that to be a success, graphical and programming. I think I do. But like outside of that, I definitely feel like that definitely seemed to be sold as a thing that could make, like it was kind of the precursor to no code is sort of I feel like the vibe was about how graphical programming was going to like fix everything. But it's just not there for like getting actual work done, right?
So all right, so I'm
it
going to
felt
take
old to me, but like a thing that was old enough that I still experienced that discussion. But I don't think anybody. We'll see what gets launched tomorrow, but I don't think anybody's selling a graphical programming thing as being the next productivity leap. So this felt outdated, but like in a more familiar way than some of the old.
Okay, but
I
no,
was born
but
in
this,
'86 too. Also, as just a small, from the
One
perspective
of
of
the
this.
one of the things Brooks talks about is the flowchart stuff, which is like really primitive attempt at graphical programming, I think, but invented by von Neumann himself and that gang. But it was taught all through the 60s and into the early 70s. Flowcharting, and it was a terrible thing. And Brooks comes right out and nails it by saying software does not conform to 2D or 3D abstractions.
amen.
I would say that you would struggle to find a software team today that didn't have somewhere a architecture diagram that was boxes and lines in an image of varying degrees of accuracy or potentially outdated, but like people do use images to to communicate with each other about the shapes of things, and that was not necessarily true of 86. Like he's talking about the fact that you just didn't have the pixel real estate to be able to do that kind of thing, but like people
I
do
think
that
people
a
were
lot
trying
today.
hard to do it in '86 because the systems were smaller. I think people were actually trying hard to represent. I actually do think that people were trying to represent systems this way. Tom, do you remember Borland Object Vision back in the day? This is like, there are a couple of these things, these graphical programming environments where we are going to like program by visualizing. And I agree with you about the diagram that people have, but those diagrams take different slices, and I don't think you can take any of those diagrams and use that to generate the system. I think that the
flowcharting was really taught as a kind of a necessary step for almost all programs, and really diagrams are a great way to explain things, but they're not directly related to the code.
it's certainly relative to like a schematic, where like when you have a schematic that actually like that is there's a very important spatial representation. And actually, this Future of Coding podcast, Steve, they are debating whether, I shouldn't say debating. One of the hosts, I believe it was Ivan, was like, no, I think I'm going to die on this hill that software has like spatial coordinates. I'm only exaggerating slightly, and the co-host is basically like, well, you're going to die on this hill because like I'm going to show you that you like prepare to meet your maker. Again, I'm exaggerating, but only slightly. But I actually do think it's important that we don't have good this idea of using a spatial representation. It's a very limited power. And Steve, I'm going to give you a hot take that's just going to get me blown up on the internet. I really question the utility of Scratch. Having watched all of my kids do it, Scratch has got a super low ceiling, ceiling. And then they don't know where to go. Like they bonk into the ceiling and they're like, I don't know how to I can't connect this like thing I've made with this cat bouncing around with like the other software that I use. And actually they go to Minecraft and they build things in Minecraft.
Mm-hmm. Totally.
Where there is actually like it's like totally like frameworks versus libraries. You know what I mean? Like in Scratch, you're super frameworky, and then you're going super library in Minecraft, where you can and that has been more engaging for my own kids. And I'm not that like Scratch is a net negative, but like I think its pedagogical utility is pretty limited.
To maybe just like add to the fire, note that I didn't say like was the best software in its class. I said this is the most successful example of this software being written. So I agree with you. I do think there's a lot of things that Scratch gets really right, but kind of inherits the sins of small talk, right? Like can't get out of that little box because you were too, in the system as opposed to outside of the system. Like, yeah, like all that stuff. And going to Minecraft and Redstone makes so much sense for all of that. So yeah, I definitely like agree that maybe there's a little bit of damning with faint praise going on there on my end.
But I also feel that like this gets to like the fundamental problem that I feel like Brooks also hits on, that if I'm going to make you 100x more powerful as a programmer, 100x more productive, I am almost certainly going to do it by really raising the level of abstraction. And if I raise the level of abstraction, I'm also going to give up some of that generality. You are going to lose. You're not going to be able to do it in any language. You're not going to be able to do it with any database. You're not going to be able to, I'm going to make a bunch of decisions for you. And those things can be great, but then you are losing more and more and more of the power of software. So you can do things quickly, but they are the things that I have preconceived of. And I think a lot of these things fall into this trap of like, yeah, okay, it does make me, an order of magnitude more productive for the problem that you are envisioning me for. But the problem that you're envisioning me for is actually not the problem that I have. Which is certainly the case with something like Scratch. And it's not going to surprise me at all if that's the case tomorrow as well. I just think it's like, have you seen Dark, Steve?
Oh, yeah. I am very familiar with Dark.
Do you consider Dark to be graphical programming? It kind of is, isn't it?
Sort of. Yeah. I mean, you're not wrong. I have to think about that for a second. It definitely suffers from the problems that we've been discussing. I don't know necessarily from like the act of programming it, if I think about that way exactly. I'm mostly familiar with the like internal stuff rather than the actual like interface of Dark, because they were in Rust and then they rewrote into F# or whatever.
Right.
So I had like looked at the Rust version relatively in depth, but have not done as much lately. I want to mention that people in the chat have been coming up with other good visual software systems that, well, I should say good in their domain, but maybe didn't break out and don't think a ton about. Like Line Sean says Simulink, just like
Simulink,
pretty good example, although it's very narrow. Emily is referencing HyperCard, which is near and dear to my heart.
Totally.
Literally, like some of the first quote unquote conference talks I ever gave were as a kid about HyperCard programs to some computer science professors. Pennsylvania had a really good science program, yada yada. But I feel like there was another one somebody mentioned that was very good too.
I think so. And HyperCard and Simulink are both really good examples because they are content to confine the solution space a little bit of like, all right, I'm going to solve like a slightly more domain specific problem, but then we can actually bring some of these tools to bear, which I think is kind of interesting in terms of like you tone down the ambition a little bit and make it a little more and sharpen it a bit, and then you got something that can actually. Because like HyperCard was used to build all sorts of things, but I think for these things they surely they are used beyond the original intent of the designers. I mean, I gotta think that HyperCard was used in places that its designers didn't intend. But
well, I mean, HyperCard was like born out of an LSD trip, so I don't think that the designers intended for there to be that much constriction on what you could do with it. But yes. Yeah, like Mist being the most famous example, as Emily brings up, but like they thought it was going to like replace the web. Like it was viewed by the creators as being very, very broad,
very expensive. Okay, never mind. Opposite of that. Well, Q. This is where Tom would recommend what the Dormouse said, just to learn that that all of computing owes its history to people who were dropping acid in the 70s.
Yeah.
Okay, then so another one they mentioned that is also near and dear to I think our heart is program verification. Yes. And again, this is done as kind of on the one hand, okay, Brooks is he says I do not believe we're going to find the magic here. So like this is not a single magical concept, but he does say it's like there's like hope for this. Like this can actually improve programs, and I think we've with the TLA plus. I mean, there's a lot of things that we can do that actually we can be much more rigorous about the way we verify programs.
Here's my super hot take on this. This is just types. Like
Oh.
the like revolution in program verification is not so much about what we think. It's almost kind of like the AI thing where like AI is perpetually just like what we can't do with computers, right? Like the definition keeps moving. A lot of the stuff that we do today would have been considered AI in like the 60s. It's the same thing with program verification, like the rise of like I think there's the history of type systems has been a little up and down, I think, but I think in the current historical moment, we are in a spot where we started to find the sweet spot of type systems that are expressive enough to not get in our way as much, but also give us a lot of the benefits of program verifications. This is like, yeah, dependent types are another example that are a little further on this step that Blaine has mentioned in the chat that I'm still not 100% sure is ever going to be real, but we'll see. But like that, the exact same problems that he talks about in this section are true of types. Basically,
that's funny.
true. And acknowledging the downsides too, right? Like, I don't think we'll find the magic. Verification is not about program verification does not mean error-proof programs. There's no magic here. Mathematical proofs can also be faulty. It can reduce the testing load, but it can't eliminate it. Like, those are all statements that are absolutely true of types as well. And yeah.
Totally. What I love that idea of like you take someone from 1986 and take them to a time machine to current day, and they're like, oh, you solved the formal verification problem. I looked at this message that the compiler just generated, and clearly you've solved it. It's like, no, that's just the type system. It's actually giving you a. That's a really interesting idea. So those things, and then where did you net out on AI? The AI, it's just amazing how current that discussion felt.
Yeah, I think that was probably one of my areas that felt most correct, and I tweeted about it whenever I read it a couple hours ago, and I got one or two good responses from people who had pointed out like that they kind of like think, yeah, it is true that it doesn't tell me what to think, but if I can quickly generate 10 different options and choose between them, that still can help me clarify my thinking, even if it's not directly telling me what to do. And I thought that was a particular, I forget who replied me with that, so I'm sorry that I've forgotten in the moment. Maybe I'll find the link and put it in the show notes. But I thought that was an interesting comment on like a pushback on this that I think is an interesting idea from the current like AI stuff that we use. But definitely, I have not really used... I've used ChatGPT a little bit for funsies, but like I have not used any of the like programming assistant tools yet because I tend to be a little bit of a laggard when it comes to adopting this kind of stuff. So I don't have a lot of practical experience, but yeah, I don't know. I definitely, what he says here resonates with me in general.
Totally. And then we and we had I think a great discussion on the promise of large language models for software engineering and what it could mean. And there's definitely stuff it could mean, but it's not as simple. It's just like it is not a silver bullet. I think we can say that with some confidence. Yeah. And so what have been we've hit on some of them, but are there any of the things that have been big step functions in your career that we've missed? So we talked. I mean, I think Rails was a big step function, right? I don't think I'm exaggerating that. I think Rails was a big deal.
I think.
Matt says in the chat, GC. That actually is a very and I definitely agree with that. Sorry, is that what you were going to
say? No, but it's close enough. Which is like, so I learned GW Basic, and then like C, and then C++ and Java was sort of my initial slate of languages I wrote stuff in. And then someone showed me Perl and specifically closures, and I went like, holy crap. And I started churning out Perl code like far faster and got way more done than I was getting done in like late 90s C++ or, those early Javas. And so that was like a personal step function. I don't know that fits into like the history of computing and was true for everyone, but I kind of have this situation where I started with static typing and then went hardcore into dynamic typing for a while. And now I'm back on basically purely static typing.
Yeah.
But like, because I think that the dynamic typing was giving me a step function over the static typing at the time. And then now I think that the static typing that exists today is giving me a step function over dynamic typing had been. But that's just like a personal thing more than something I'm willing to generalize to the industry at large.
I mean, for whatever it's worth, that's my path too, right? That's like a hardcore C, and then like realizing like, oh wow, JavaScript could be used for a bunch of these things, not just on the browser. And then realizing like maybe that was actually a few too many things. Maybe we can This Rust thing is pretty interesting. So
And to kind of like bring that into the GC thing too, like Patrick Walton has this really interesting thing. I hope I don't misrepresent what he said on this before, but it's like Java did, like, as much as we did say Java didn't save the world, like earlier in this podcast, for example, like it did seriously eat into the market share of like application software for C and C++, right? Like, did it solve every problem? No, but like those used to be the default choice. You're building a desktop app, you write it in C or C++, and then in that time period, it moved to Java, and GC was a very large part of that being true, right? Like for software that didn't need every single last bit of performance, it allowed a lot of people to get a lot of work done. So
well, and that was my
for whatever it's good or bad.
Well, no, but my first impression when writing Java was this is the end of C++, because this eliminates now. I mean, I didn't think of it this way at the time because I had not read Brooks's paper moments before. But looking at it in hindsight, Java eliminated so much of the accidental complexity of C++ and distilled you to the essential complexity. Of course, it generated accidental complexity of its own, but I'm like, this is going to be the end of C. Well, why would you write in C++? And of course, I underestimated the C++ diehards that they would definitely have their own resurgence. But yeah, I think Java was a very big deal in that regard. And I mean, Java made the mistake of overshooting a bit, but it was a very big deal. And then, I mean, I think we didn't talk about cloud computing, but cloud computing is a huge deal for accidental complexity around infrastructure, right? I think hard to argue. Orchestration feels like we haven't yet had. I mean, Kubernetes is super complicated, and I'm not sure that Kubernetes is in the book, as Paul Erdős used to say, of proofs that he felt to be sufficiently elegant that they'd be recorded in the book of the supreme fascist, which is his name for God. I don't feel like the Kubernetes is in the book. I'm not sure though.
Yeah, we'll see. I kind of feel like, Apple never like releases something, but never releases. They're never the first. Like the iPhone was not the first cell phone that was like even smartphone, but it just like became product defining. Like,
okay,
I have not used Kubernetes in anger enough in production. Like I kind of got into that whole working on a programming language thing around the time that became sort of the cool kid thing to do for web apps. But I feel like there's going to be a sequel or a second system that comes out that makes it better. But I don't know what that is, and I'm not willing to bet that's true. So like for everything, but just kind of
is it coming from Apple specifically?
No, but just like that sort of like an outside somebody, not like them turning it, like it's not like Kubernetes 3 or whatever is going to be like the best.
Right.
It's like some outsider seeing the space and then reworking all of that stuff to be on some sort of simpler or better primitives. We will see.
Oh. Yeah, and I think that these like lurches that happen, I mean, they do have some things that they have in common. One is that when they're not being pre-announced as 10x or 100x improvements. They're kind of pulling together. I'm just like thinking about the things that we've talking about: Java, Rails, Rust. I mean, Detroit's for that matter, where you're pulling together a bunch of existing ideas and kind of packaging them up in a way that is expressing their usefulness and eliminating a bunch of accidental complexity, but done in a way that like the creators really did it for themselves. Java was done for Gosling, more or less for Oak in the set-top project. Rails clearly done for DHH. Again, we talked about Unix and certainly. So I feel like there's something. These things have something in common. There's some properties that these big step functions have in common as individual technologies, and then there are these other step functions like internet, open source, distributed version control, which feel like they're even more broad-based and are even more radical over time, but just take it's not like there's some grand reveal for, and now, ladies and gentlemen, the internet. It was more like this is something that was available and then became more ubiquitous, and a bunch of things unlocked that. I don't know. In terms of like these indisputably a huge step function, but took a long, long time to unfold.
Yeah, sharing software was always a big part of the buy versus build. If you could get it for free, but the internet made sharing, the mechanics of sharing, so much easier.
Totally. Yeah. And then distributed version control, even easier. You could actually you're not downloading tarballs from SourceForge, or what did we used to do? Tom, what did we do before GitHub?
Fresh
I
meat.
don't remember.
Yeah, SourceForge.
C-SPAN.
That's right. Right.
I have some
Right.
books that publish the software in the back of the book.
Right. There you go.
Invite only BBSs.
The discords of their day.
Yeah. JBK said something in the chat that is reminded me of one of my favorite quotes actually from the paper. JBK says, I don't know if it counts for programming productivity, but going way back, what about the whole concept of pipes as an operating system concept? And in the Ada section, Brooks says, operating systems, loudly decried in the 60s for their memory and cycle costs, have proved to be an excellent form in which to use some of the MIPS and cheap memory bytes of the past hardware surge. And having people and companies argue I don't need an operating system because it uses too much, resources, it's not worth it or whatever, is a thing that we just now take for granted as a tool that we build software on to be productive. And an OS is itself a platform.
That has a bunch of, it turns out, a bunch of useful things associated with it. I mean, things like McIlroy was obviously a big lurch forward. And yeah, Matt, it's funny. I was just going to mention the same thing. Have you heard about this with the Knuth McIlroy showdown?
Oh yeah,
Steve. Yeah, exactly. Where Knuth writes a 5-page algorithm, and Knuth writes it as a pipeline, which just feels like I always thought was I think practitioners everywhere, even though people are right to point out that well, it's kind of that wasn't really the spirit of that, and it's I don't care. I just find it very entertaining. As a practitioner, I am entertained.
Brian, I want to jump on the opportunity to correct your pronunciation. It's McElroy.
It's McElroy. Thank you, Tom. It's is it misspelled?
No, it's just a weird spelling.
It's a weird spelling. All right, McElroy. Thank you, Tom. Well, there you go. This. Listen, an important theme in this podcast is correcting my pronunciation for essentially everything. As we've learned, I mispronounce absolutely everything. Well, if it's yes. No, listen. You can pry Svig out of my cold dead fingers, Ian. It's been great. This is Steve. Thank you very much for being willing to jump in here as philosopher and podcast host. Exactly.
Thanks for having me.
No, really appreciate it. And Ian and Tom and Alex, thank you. Sorry that thanks to everyone for all of your contributions. A lot of interesting stuff in the chat. We're going to be definitely interested to see the magic bullets of the silver bullets of our future. I'm sure there will be some, and I'm sure they will be somewhat valuable, but I think we can broadly stand by a lot of the conclusions here that Brooks made. Coming up on 40 years ago. This is pretty old to be able to make things that are actually remain really quite current. Very, very impressive.
For sure.
All right. Thanks, everyone. We'll see you next time.